Hello, this is the first demonstration of the B-Fisher 4 platform, and this demonstration is for UNCTAD, specifically the Special Unit on Commodities. Once you've downloaded the software and installed it on your phone, you can stand in front of your house and push the code button. This initiates a conversation between your phone and your GPS satellites to determine the position of your phone. Once your GPS coordinates have been obtained, they are transformed into a 7-digit alphanumeric code. This takes a few seconds. As you can see, the code that it has determined for this particular phone is PEYJDSN. This code can be forwarded on to a company or via email to any other organization if one so wishes. But for this demonstration, we don't need to do that. Once you've got a code, you can locate the code. But before we do that, I want to show you what happens when you make a mistake. A lot of times people hear S's as F's. So if I heard this code as an F, if somebody was to tell me this code over the phone and I heard it as an F, and I entered it in, and I tried to locate this place, it will tell me I've used an invalid target address. So it stops me from setting off without a concrete and correct address. And this happens this is correct 97% of the time, i.e. if you have made a mistake, it will correct you 97% of the time. If we had entered it correctly, all we have to do is push the locate button and it locates it for us on the map. As you can see, it's using absolute GPS coordinates, so it doesn't matter whether there is a road there or not, or whether there are any landmarks, it is able to pinpoint the exact location. So as you can see, it has pinpointed the location halfway along Bamboo Street. And all of this has been done without any house numbers. So the code basically encapsulates house number, street number, town, area, everything into those 7 digits. And it is self-correcting. In terms of accuracy, this system is accurate to, on average, plus or minus 7.25 meters. To demonstrate this, I'm going to ask you to plot the route between two separate addresses. And as you can see, the distance between these two places is only 9 meters. And so it's accurate enough to distinguish between houses. It is also accurate enough to take you halfway across the country or all the way across the country with no errors. Now I've made a mistake in the endpoint, so it has corrected me. And once I've got it right, it proceeds. And as you can see, it has taken us from our house in Accra all the way to Kumasi. But not just anywhere in Kumasi, but to the Kwame Nkrumah University of Science and Technology, and more specifically to the main entrance of the university hospital. The system also works in totally uncharted territories. For example, NM, NMVR2HC is the code for a patch of dirt road which is literally in the middle of nowhere. But as you can see, the system is able to cope with that. It is, if you look at the directions, it takes us from Bamboo Street all the way to a road called Unnamed Road. And when we zoom in, we can really see that this road is really in the middle of nowhere. And it has plotted that location to an accuracy of about 7.5 meters. So to conclude, we have seen that the software is able to generate over 410 million different postcodes for the country of Ghana. It is able to cope with isolated areas and able to cope with very long and very short distances, making it suitable for community outreach programs, surveys, and so many other things. Now, there is an interesting thing to note. When you have these 7-digit codes and you've collected a number of them, say at a hospital, you can now start plotting exactly where incidents of malaria or cholera or whatever disease are popping up. And this is just one example of it being very useful in fields like epidemiology. This is the end of demonstration 1.